welcome to the Primary Science Podcast in this final episode of our mini-series exploring inquiry skills in primary science education. Throughout this mini-series, we've been looking into the teaching and development of these inquiry skills in the classroom. Today, we'll be shifting our focus to a very critical area: assessment of the inquiry skills. Ladies and gentlemen, we're very, very lucky to have Professor Sarah Earle as a guest on the show. She's one of the brilliant minds behind the TAPS assessment tool and a professor of primary science at Bath Spa University in the UK. She's here to help us navigate those complexities of assessing science inquiry in our classrooms. So let's go ahead and meet Sarah. Sarah, welcome to the Primary Science Podcast party. How are you doing?
Oh, I'm well. Thank you for having me. It's exciting talking across the nations.
Yeah, I still can't believe that I've managed to get a guest such as yourself, a professor of primary science, on the show.
Well, there's not many of us about. It's quite a niche field, but it's important to fly the flag for primary. That's what we're doing.
Yeah, absolutely. Yeah, it definitely needs a lot more people such as yourself, for sure. Before we go in deep into primary science and assessments, I just wanted to do something a little bit fun to get to know you better. So it's something I do with all my guests. Are you ready for the quick fire 5?
I'm not sure about the quick fire bit, but go for it.
The slow fire 5. Okay. So question 1, I wanted to ask, what's one thing that every teacher should have in their science inquiry toolkit?
Something that everyone needs if they're doing primary science is an open mind. Just go with the flow with the children and don't be scared if they're asking questions, because question raising in science is what we want and it's really important. So yeah, don't feel like you have to know the answer to everything. We want to be inquiring with the children.
That's right. Yeah. Almost modeling the fact that you don't have all the answers, that science is about getting those answers. Nice. Okay. Question 2, what is your favorite book or resource on teaching primary science?
The resource that I think is the one that it's been around for a long time, but it kind of comes in and out of fashion a little bit. So there's something called fair test planning boards, which is something that really helps to structure an investigation if you're trying to do a fair test where you're controlling variables and stuff. And it's something that's just really useful. And I don't know, there's lots of that kind of thing available on the internet, or you can make them yourself. But it's just a way of structuring an investigation. So yeah, fair test planning board will be my go-to thing that I'd carry around with me, I think, just to help structure the thinking around it, because obviously there's a lot going on in the classroom. Another name of it is post-it planning. So like you're coming up with lots of ideas of things that you can change, then you pick one thing to change, and then all the other things that you thought of are now the control variables and stuff. So it's really good with those older primary children to just help them to see how an investigation works, if it's a fair test one.
I see. So it's more of a display board thing.
It can be a display board. It can be just writing on a screen. It can be paper printed out, a card or whatever. There's lots of versions of it. But as a resource, the idea of it is that it's structuring a fair test planning discussion. So yeah, that's the one that I would recommend.
Okay, yeah, we'll put that in the description. Okay, so question 3. If you weren't teaching science, difficult one to answer here, or if you weren't in the field of primary science, what other subject do you think you might be into?
Yeah, this was hard because I'm primary through and through. I'm not a science specialist really. I was a primary school teacher for years, and so I'm used to teaching all the subjects. But obviously there are some that you're better at than others, and I wouldn't be picking PE or music, for example. I'm not very coordinated, but something where you're also inquiring, like history or geography, or maybe even something where you have to think really hard, like philosophy. I don't know. Philosophy for children would be really interesting to explore. So yeah, something where you're inquiring or thinking hard might be fun things to look at as well.
Yeah, so the topic subjects, geography and history. I think I might be with you on that one. Luckily, I do get to teach some history and geography still. So although I do wish I was teaching more science all the time would be fantastic.
Well, that's the joy about teaching primary is that you've got all the different subjects usually that you're and you can make the links between them. That cross curricular stuff is just something that doesn't happen
Yeah,
in secondary school. So yeah, there are lots of advantages of being in primary, and the variety I think is just really interesting as well. That you get to teach all these different things. Yes, you might not be an expert in everything, but yeah, it's just the variety that makes it such an interesting job. Oh, as well as the
yeah,
children, of course, who are always
yeah,
entertaining.
absolutely. Yeah, absolutely. Okay, so question 4. What's the best piece of advice that you've ever received about teaching science?
I think this could apply to anything really, and when I made a note of this, and then I thought, oh, that sounds really mean, but actually, when someone said, "So what? What is it that you're trying to do?" And that "so what"
Okay.
question really sticks. I mean, primary science quality mark use it a lot as well, but it's one of those things that is, yeah, what are you trying to do? What is it that you're trying to do? And then it really helps you to focus in on what you're looking for. But yeah, so what I think is a really good nudge from a colleague to say, "Yeah, so what are you doing with that?" It's like, okay, you're doing
Yeah.
all these things, but so what? What's difference is it making? What impact is it making? And it just helps you say, I think it helps me say no to stuff because you can't say yes to everything. So it's just
Mm.
like, okay, is this going to have an impact? Because if it's not, then I'm going to have to say no to this or
Yeah.
stop doing some stuff because stopping doing stuff is just as important. We can't do everything.
Yeah, that's true. That's true. And I guess, does that apply to things in the curriculum as well? Like, we have so many conceptual objectives to teach the children about all of the answers in science, right? Rather than the inquiry side of it. And is that still something that we could ask ourselves, so what about, and perhaps adapt that while still, of course,
Yeah.
teaching to the curriculum,
Yeah, and
but
the where to stop bit is really interesting because yeah, the content bit is where do you stop? Because if you're talking about something really difficult and tricky like magnetism or something, there's no way
mm,
we're going to be trying to explain the detail and what's happening at atomic level. And no, I'm not sure anyone even knows the answer to that. But it's what's appropriate, what's age appropriate for the children who
mm,
we are teaching, and it's sort of recognizing that forces act is at a distance kind of thing
mm,
is something that we don't need to go into too much further than that. It's hard because you want to have all the answers, don't you? But yeah, they've got plenty more years at school and other years of their life to learn about those kind of things, and so we're
yeah,
just starting them on that journey in some ways. And yeah,
yeah,
deciding where to stop is quite tricky.
yeah. It's almost being more target driven.
Maybe, or maybe just it's sort of saying sometimes, well, if the discussion with the children is going in a certain direction, of course you can have that discussion, and there's no reason why you can't go into things that are hard. But does every child need to know that to be able to achieve, to
Mm,
be able to
mm,
meet expectations, to be able to pass at the end of the year or whatever? And the answer is no. These are interesting discussions to have, and going a long way down one particular concept is really interesting, but not every child has to get that before you then move on. So it's kind of that difference between, and I suppose that's where assessment comes in, is what's the core thing that you're trying to teach, and
yeah,
if you go beyond it and use other language and use higher ideas, that's fine. But not everyone in your class has to get all of those things. It's what's the core thing that you're trying to teach. So I think
mm,
most of my work is trying to work out, well, what is the what is the focus? What is the age appropriate stuff? What does it look like? What does a good one look like at age 7 or whatever,
mm.
wherever you are in the world? So yeah, I don't feel like
Nice.
I've got all the answers to that yet, but we're still going.
Yeah, that was a yeah. I think I could call this segment the not so quick fire five,
Exactly. No, it's impossible.
but it doesn't.
Once
Yeah,
you
it
start
doesn't need
opening
to
the
be
can of
that quick.
worms.
Okay, so we are on to the fifth and final question.
Woo!
We made it. Woo! What's your favorite assessment tip for teachers who are short on time? Which is all teachers.
My favorite tip, I think, is you don't have to write everything down. So if you spend a lot of time recording it all or getting the children to write everything down, and that's mostly just a handwriting lesson. So yeah, it's going to have much more impact if we do something about it straight away or in the next lesson. That's get straight to the impact. Don't spend hours writing up reports about or trying to log it in great detail. Primary science. It's there's so much of it. We can't do that for everything. We'd be there forever. And we don't teach it as much as the language or the maths. So yeah, there's just not the time to write everything down. And I think we'll come back to that a bit later.
Okay, so I think that's it's a really good time now to just start diving into the real heart of our chat today, and that's about assessing the science inquiry skills. And so I guess kind of my first focus question was to ask why you might think that assessing science inquiry skills is often seen as being a lot more challenging than assessing other subjects or other skills.
Yeah, I think it is. It's not just seen as it actually is. It's really hard because it's all going on at the same time. You've
Mm.
got a class that you're trying to manage. They're all doing something. If you're doing the doing bit of inquiry, and a lot of the interesting things that they're doing happen in the moment, and then they're gone. So it's that kind of how do you capture that is really difficult. You you may get children to write some stuff down, or you may be making observation notes, or you might be looking for things, but trying to write everything down is hard, and it doesn't really tend to capture what's happened in the moment. So if the children do a write up or whatever, it doesn't capture what they actually did often. And if you did I don't know, a pencil and paper worksheety thing or some sort of quizzy thing afterwards, it just doesn't seem to capture the whole complexity of what was happening. So there is a lot, and the challenge for us as teachers is to try and work out, well, how do we keep an eye on all this stuff at the same time? Everything is happening, and everyone's moving and doing stuff, and I don't know, rolling things or dropping things, or all that stuff's going on. How do you cope with all of that happening at the same time and still be trying to look at the learning? And so I think, yeah, that is a massive challenge. We have a way around it, I think, which we want to talk about, but it's just, yeah, acknowledging that it is more complex than trying to do something where you're able to write everything down. And plus, with younger children as well, they're not going to be writing everything either. So yeah, I think it is a challenge because it's just happening, and how do you capture
Mm. Yeah, it's almost like trying to assess art, an art form in a way, right? There's so many different things going on at the same time. It's not like with assessing mathematics where you have a right answer and a wrong answer and a few different ways of getting there. There's a million different ways it could go with inquiry.
Yeah, and obviously there's a decision about how open that is as well. So, and that depends on the investigation you're doing, I suppose, and what the purpose of the thing you're trying to accomplish with the children is. So sometimes it will be really, really open, and it could go in lots of directions. Other times it's a bit more tight, and there is a right way of doing it. So yeah, there are no. Um, the answer is always, well, it depends.
It depends, yeah. Um, so you mentioned there that there might be a way around it. Is that to do with the TAPS assessment tool?
Yeah, so TAPS stands for Teacher Assessment in Primary Science, and it's the teacher that's really important in this, because it's part of teaching and learning. So this project has been going on for like 11 years or something ridiculous. It's a really big, long project that was funded by the Primary Science Teaching Trust to start with. So if you Google PSTT TAPS, then you find lots of stuff on the internet. The first thing you might see, one of the things you might see, is a pyramid, and that pyramid has the sort of the principles behind TAPS. It's kind of the theory behind it. It's shows how there's lots of different things that you can assess in the classroom, lots of different things that you can do, and some of those can be summarized when you need to. So formative assessment, the blue layers of the pyramid are the most important. That's what you're doing in the classroom with the children. If you need to pass some information on to the next class teacher, then you can summarize some of those. So that pyramid has examples in it. So if you're wanting to meander around the internet looking for peer assessment, self-assessment, that kind of thing, examples of what this looks like in practice, then feel free to play with the pyramid. However, that's the principles behind TAPS, the stuff that people use straight away, and the things that we suggest that you start with is the focused assessment approach. And this is the way to assess primary science skills. So the focused assessment approach is the idea that you're still doing a whole inquiry, but you pick one bit to focus on. And that could be the planning of it, that could be the measuring, that could be evaluating, but just one bit is the focus for you and the children to try and make a judgment about, I suppose. It might be the children might make some notes about it, or they might record that individually, but the whole inquiry is happening, so we're not taking it out of context. We're still doing the whole investigation, but there's only one bit that you're looking at, and I think that's the most important thing out of anything that's said today, is that you pick one focus, because that just makes everything else easier. It makes it easier for you to watch. It makes you easier to make decisions. It makes it easier for you to know what you're looking for, and it also makes it easier to make a judgment, which you can then summarize if you need to, or just work out what to do next with the children. So yeah, there's lots and lots of examples of that on the Primary Science Teaching Trust website. So we've got examples of children's work, we've got examples of lesson plans of how you do that. So yeah, if you find the pyramid first, of course that's interesting stuff, but if you're completely new to all of this, then start with the focused assessment approach and look for some examples of lesson plans or something like that, where it will just show you what does this look like in practice. Because yeah, just picking that one focus makes a massive difference to how you teach and assess in the classroom, I think.
Brilliant, thank you very much. A detailed answer there. And one thing that comes up a lot in my conversations with colleagues is about a lot of teachers might feel a bit unconfident about teaching science. Maybe it's not their background. Is TAPS something that anybody could easily get to grips with?
Yeah, so like I said, the focused assessment approach is where you start, and whether you're confident with science or not. I mean, obviously, confidence in teaching science is the same as everything else. We have to learn a bit about it, and then we feel a bit more confident. And I think the reason why the focused assessment approach, where you pick one focus, and that helps you decide what to do next, and helps you to work out what to record with the children and things, that is a confidence builder, because it makes it easier to know what you're looking for. So on all the example lesson plans, there's assessment indicators at the end of it, which just say this is what you're looking for the children. If this age group of children, this is what they should be doing, and if they can't do it, then let's do something about it, and if they can, then carry on and move on to something else. So yeah, I think it's definitely the place to start with the TAPS materials, that focused assessment approach.
Yeah, brilliant. It sounds like it's made and specifically designed for any and all primary teachers to make this a structured, simpler process for what is essentially, as you said at the beginning, a really complex thing to do. So yeah, this is definitely a really useful resource and tool for primary teachers when it comes to assessing science. And kind of following on from that question, what should teachers really be looking for when assessing those science inquiry skills? Sort of what's the key to getting it right, if there is a key?
Well, I mean, I don't want to keep repeating myself, but the key is having a focus and deciding on that. So whichever nation you're in, there will be some list somewhere of what the curriculum says you need to be teaching or whatever. So that's always a useful starting point. Often that comes as a list, And it's quite hard to decipher sometimes. In some nations, there's a lot of detail; in other nations, not so much. So it depends on your context. But yeah, if you've got a list like that on your curriculum, then those are probably the easiest things to start with. Of looking, okay, what is it that I'm meant to be assessing here? But wherever you are in the world, whichever nation's curriculum you work with, the process of science inquiry, where you're planning something, then you're doing something, then you're reviewing something. It's like method, results, conclusion kind of thing. With the focused assessment approach, we suggest that you pick one part. So if you are, I don't know, doing something like rolling cars down ramps, very classic investigation, rolling something down a ramp. If you decided you want the children to collect some results, that's the focus of the lesson. So you, as a class, you're discussing, where we're going to put the ramps, how high we're going to have them, how we're going to set this up, how long we're going to have to do this. So you do all the planning together as a class. Then they go off and they do their recording of results, and whether that's individually or as a group depends on what class you've got and stuff and how old they are and things. But there's some sort of recording of results, and that's the bit that you're interested in. And then you bring them all back together and they're having a discussion about what that means and stuff. But because the recording results was the focus, then you've now narrowed it down to, when you're trying to make assessment judgments, you're trying to decide, okay, well, these results tables now I've got all in front of me, are they clear? Do they have titles to tell me what the things were being changed or measured? They measured in particular units? Is that clear? They're measured in centimeters or meters or seconds or footprints or what? How do is it clear? Could I repeat that investigation using just that table? So looking at the spread of tables helps to decide where your class is and what to do with them next. So there was a teacher I remember working with in Wales who did a lesson, not car ramps, a different one, and found that the children couldn't draw results tables, which was a surprise to her because they were 10 and she thought they would be able to. Year 5 in England, we always expect them to be able to draw tables, and my year 5 class could never draw tables. It's always this thing, because you kind of think, they've done it before, but actually in this context, can they remember how to do it? So found that they couldn't, and then so okay, so you need to do something about that. You need to we need to show them what a table looks like and how to draw a table, and then obviously then they can use that again. But it's not just all about tables though. So if you're doing something, string telephones, so thinking about sound down the string and things, that's a really good one for drawing conclusions. So they explore, they make string telephones. They might try different strings or different cup sizes, different ways of connecting them, get it working, realize that they have to have the string taut to make it work, all that kind of stuff. So all that exploring and investigating together, and then they could individually tell you on a post-it note or in their books or wherever, or present to the class if you want to do it orally. But what's the conclusion? So what makes a good string telephone? Now, if they're only talking about the colour of it, or it worked, but not explaining how, or this one's my favourite, or our one was the best, it doesn't really tell you that they're scientific thinking. Whereas if they're talking about, we needed to keep the string straight so the vibrations could move down the string, well, then they're applying their scientific knowledge. So having that focus helps you decide not only how to structure the lesson, but also makes it easier to make a judgment about it. So what you're looking for is, can they do the thing that I've chosen as the focus, or that we together decided? So can they do what I wanted them to do? And if they can't, then let's do something about it next time. Or I'll ask them some questions to see, well, can you give me a because for that, and all that kind of stuff. It helps to know what a good one looks like, because you have given them the opportunity to show you, I suppose.
Yeah, and you, thank you very much for that answer, by the way. That was really good. Lots of practical examples as well, which we like. And you did touch upon the post-it notes idea there as one of the ways of getting feedback from the kids. And I think when I've used that for any type of kind of mini plenary or assessment in a class, it's always worked really well, because it's very quick, it's very informal. got to make sure they write their name on the post-it, and then you can at least see which students are on the right lines, which ones are sort of understanding this specific type of investigation or this activity that you're doing. So yeah, I think I would definitely second that as a really good method for getting feedback. You also mentioned the presentations at the end as well would be a good way. Would you use that as assessment, or would you be worried that maybe if they're presenting in groups that some of them might just be showing that they understand in this kind of presentation assessment, but actually it's just because their partner understands? Or how do you differentiate who really understands with presentations?
Yeah, I think it does depend on what you're looking for as to whether is the presentation of it an actual thing that you're trying to tick off almost. So, for example, in the Scottish curriculum, presenting results is a whole different section on its own in their list, and in other curricular documents, it's just one of the many ways you can do it. So. I think it depends a little bit on your context and your curriculum, and obviously also the age of the children. I suppose the time taken to do presentations is quite a lot. It's because you obviously have to go through every group. So it's whether they're all going to say something different and whether it's worth the time and effort spent on it. So, for example, if they were doing a research kind of inquiry where they were going off and finding out about different planets, and every group had different planets to look at, that might be something that would be interesting for everyone to listen to. Whereas if everyone is making a presentation about the same investigation that everyone has done, it's not so effective or useful for time purposes, and everyone's done it and who's presenting kind of thing. So yeah, I suppose I don't use a full presentation bit and a big report thing very often. It would be if there's it's if they're trying to do a persuasive investigation, almost if they're trying to persuade that do an almost like an advert. I'm just trying to think. There was one I did where children were trying to work out which was the best paper towel, which was the most absorbent, and had to kind of do an advert for that. I suppose they don't all have to present at the same time as well. It could be videoed, and they could be presenting to each other and that kind of thing. So it's what's the presentation for? It might be just drawing together their knowledge. It's not necessarily the focus of the lesson at that point in time. It's kind of drawing together everything that they've learned about X, Y, and Z, and an end of topic kind of thing. Yeah, so I think, I'm not sure I've answered your question really, but I think the deciding whether a full presentation is going to be the best means for finding out what the children know and understand is, you have to decide whether it's worth the time taken to do it, I suppose, and whether individuals within a group are pulling their weight almost. That's something that's very, very child specific, isn't it? And I think it might a group presentation where it's not clear what everyone has done is not a great way to make an individual assessment. So yeah, I think that's why I'm hesitating to say that presentations are the all and end all, because they're not great for lots of things, but they are good for sharing results and findings where people have investigated different things, perhaps. It's got me thinking.
Yeah. No, you make a really good point there, actually. I guess you got to ask yourself, so what, right? Just like you said at the beginning, is there a real reason why we're doing this presentation, or is it just for the sake of it, or are we assessing their presentation skills and so on? Yeah. I guess kind of on the other side of the question that I asked, I'm kind of trying to just for myself as well, trying to understand, say I'm in that classroom and we're doing this investigation with my students, what's the best way or one of the key ways for me to start assessing? And I'm sort of guessing it's probably more like questioning the children. So sitting with groups, asking the children to tell me what they found out, and then having specific questions set up ready to check for understanding. Is
It
that?
could be. Again, it depends on what the answer is always, it depends to every question. It depends on what your focus is. So, for example, planning is a really hard section to assess because it's kind of, you either get them to write it all down as a plan before they've done anything, and then they have to change it anyway, because they go, oh, well, that car won't work, or that ramp is too high, and that kind of stuff. Or it's something that's ongoing, and you need to see it in process. So yes, some of it will be watching and seeing, because the child might say, for example, with fair testing, they quite quickly learn you only change one thing, so they can almost parrot that off. You're changing just one variable or one thing,
Hmm.
one yeah, we're just changing the car, or we're just changing the ramp surface or whatever. But actually, when they come to do it, they try every possible different thing, and it's more of an exploration than a controlled investigation. Um,
Hmm.
so yeah, some of it will just be standing back and watching. I think because if you've chosen a focus, you're clear about what you're looking for. Then sometimes you'll be watching to see whether they can, and then if they can't, you step in. It's not a test. I think that's a big thing to flag up. When we say assessment, we don't mean a test where they're doing it independently and we're just watching them, whether they're writing or drawing or whatever. What we're saying here is that we want to use assessment formatively. So, assessment for learning, responsive teaching, adaptive teaching, all of these terms, they all have a very similar meaning, that you want to support the learning. The assessment, the judgments that you're making are all about trying to support the learning, and that might be right in the moment. So if you see a child trying to measure with a Newton meter or a ruler or a stopwatch, and they're not able to do it, then of course you clock that they can't do it, but then you show them how, and showing them how there and then helps. So yeah, some people wander around with a clipboard and kind of note down who can and who can't, but
Hmm.
other people clock that in their head, because you're looking for the ones who can't. Those are the ones you're trying to find. You're looking for the gaps, the ones who are struggling, and remembering who was away. But everyone else is, yeah, you kind of, as long as everyone's going okay, then the class carries on. And if everyone's not, then you stop and say a mini plenary and say, okay, we're really struggling to get this right, or everyone's got their Newton meters upside down, or whatever, or that kind of stuff, or no one's able to measure things, or we're not looking at the level when we're measuring the water out, whatever it is that you've spotted that they
Hmm.
can't do. So yeah, I suppose we don't start assessing in that we're already doing it probably without realizing. So a lot of what you're doing in class, what everyone's doing in class, will already be involving assessment. You're already judging whether they've got it by the look on their faces. When you get a sea of blank faces and no hands up, or however you run your class, you go, oh, okay, I need to explain this again. You've just used assessment formatively there. So the feedback from the children you're constantly getting. And sometimes you want to, because you can't hold it all in a head all the time, you might want to make
Hmm.
notes of that. So you might make notes as you're observing the children wandering around, or you might get them to record something. So if they're older and they're writing their own conclusions, that's the bit that I'm assessing. And so I've got the 30 conclusions, and I can decide, I can put them into piles: got there, not yet, gone further, kind of 3 piles at the end of the day, or whatever. So yeah, it's being aware that you're already assessing and making judgments, and recognizing that is useful, I think, because we don't want assessment to be something that's separate and different, a bolt on, that we're already doing it, and we can feel more confident about doing it if we know what we're looking for, and that's where you get the focus bit.
Got you. Yeah, I guess you kind of already answered my next question as well. That was one of the golden nuggets there, I think, to understand you're already assessing. Because I was going to move on to talk about um, any advice you have about teachers then using this data, this assessment data we've collected. But I guess if we're assessing as we go, then of course we're using it to then teach in the moment and
Yeah,
teach
yeah,
to
but
those
I,
gaps.
I think it is worth exploring what we mean by data, because it's really easy to hear that word and think, oh, okay, we need a spreadsheet of numbers. And maybe that is the case in some situations with older children or students. But what we mean by assessment data in primary and with younger children is the things that we are seeing and doing all the time. The children might have recorded something in words, but they also might have drawn a picture. They might have drawn a diagram. Diagrams are brilliant for making judgments about whether they understand shadows, for example. So if you get the children to draw how a shadow, draw their shadow, or draw how a shadow's formed, and label that, that gives you so much information. So I suppose I just wanted to make sure we've widened our sense of what data is. Data is, or the stuff that feeds into the pyramid in the TAPS model is everything that you're doing in class. It's all those observations you're making. It's all the things that you see and hear the children doing, anything that they're drawing or writing, predictions on a post-it, whatever. And if you're using low stakes multiple choice quizzes, that's another piece of information. Not so useful for inquiry type activities, but still useful if you're trying to find out whether they've learnt that particular thing about the moon orbiting, or whatever it is that the particular science conceptual understanding you're trying to get to is. That science content can be got at through a low stakes quiz. But my key point is that that's only one way. There's loads of ways to elicit children's ideas, and we use all of them in the classroom with all that discussion and talk that you're doing all the time. And as teachers, because we've only got a limited amount of time, we want to try and listen out for the bits that are hard for them, the bits they're struggling with. Yes, it's lovely to see all the things that they're doing right. Fabulous, move on. But what we're looking for, the really interesting things, is when the children are surprising you, and they can do it or they can't. But when they're surprising you, that means that they've shown you something that you didn't know, that you didn't assume that they would be able to do it or they couldn't do it. So going back to shadows, for example, if you've got all the children's drawings, and you can see that they haven't got any light source in there, there's no sun or torch or whatever to make the shadow, then they need some more exploration of making shadows before they can then go on to measuring shadows or whatever. So what we're doing is our everyday teaching and learning activities, but we're using those to inform the next steps in our teaching. And if you need to summarize things to pass on to the next class teacher or to pass on to parents, that's summative reporting. You're describing all the things that they can do and maybe the gaps they haven't. But yeah, that kind of converting everything into numbers is almost, I don't know, a bit too time consuming. That doesn't give me enough information back. I want to know I don't want to know the number. I want to know the gaps. What was the content that they had trouble with? That's the bit that I'm interested in to help with their learning. I'm not sure that's the question.
Yeah, you did, and from so many different angles as well. I really like the idea of getting the kids to draw diagrams and pictures, because especially working in an international school, one of the major obstacles that we have is students speaking English as an additional language. So they might find it quite difficult to communicate their exact understanding of a particular concept or an experiment they did, or how lights and shadows work. But in a picture or a diagram, that's a really great way that we could use as an assessment to assess that child's understanding. So I really like that idea.
Fab. Yeah, no, drawings are one of my favourite things, and model making as well. I mean, you can get with the youngest children make a body, and they have to try and put cocktail sticks in to label it, kind of thing. Label the different bits of the body, or label the flower, or that kind. There's low. I mean, this is where you get, is this a teaching activity or is this assessment activity? And obviously there's this massive overlap. But when you're making a judgment about whether they can do it or not, that you're using it as an assessment tool. But it's the same tools that we would use for teaching as well. So we want to, The other thing to say is that we want to find out what the children know when we're starting on a topic as well, because this is where science is different to other subjects. Science, the children come with their own common sense explanations for the world. They've already worked out why things drop and roll and that kind of stuff when they were young, and they might have a picture of the world in their mind that doesn't quite match the scientific reality. Now, in other subjects, that's not particularly the case. If they've never learned about the Vikings, they're not going to know what the Vikings is, or whatever, or whichever historical period you're studying. So yeah, preconceptions about the world, the children come with those. So we need to find out what those are, because they might have been using. They might have this picture in their head, but it might also be words as well. So they might have been using the word reflection for shadow for years without realizing that that's the wrong word or whatever, because reflection and shadows often get mixed up with young children. So yeah, it's what do they already know, as well as later on what do they know now? What have I taught them? What have we worked on together?
Brilliant. Okay. And then my last question would be, we've covered so many different things in such a short time today. I just wondered if there was anything else crucial that we haven't quite spoken about yet today to do with assessing primary science.
I think probably because we've meandered around lots of things, then I may have said these things before, but for clarity, I suppose, just the core thing of assessment is part of teaching and learning. So what we're trying to do is to support the children's learning. That's the so what. That's the aim of all of this. And so that formative use of assessment is the most important. That's where you put your energy, get straight to that impact. Don't spend hours writing, filling in, converting everything into numbers and then putting it on a spreadsheet and that no one ever looks at. It's okay, so this child is asking me a question, or this child is showing me something that they can or can't do. What am I going to do next with that? And acting in the moment saves our time and theirs as well. So that formative use of assessment is the most important. And then the other thing I think is just picking that focus in an inquiry in particular. So if you're doing a whole investigation about cars down ramps or whatever it is, what is it that's the focus for that one? Because when you do an investigation next time, so if you're doing a unit on forces, then the next investigation will be pulling shoes across the floor or whatever it is. And so as long as you're focused on different things every time, so it's not recording results every single lesson, then across the year or the couple of years, you get a spread of the different parts of the scientific inquiry cycle. And so yeah, you cover the whole thing across time. And as primary teachers, we've got those children for at least a year, sometimes more. And so we can explore these things with them. And I suppose my last thought is to explicitly give permission to not write everything down. You don't have to write a full write-up. No one needs that time that's spent on that handwriting lesson to be about science. Of course, if you want to cross over and do report writing in your literacy lesson and all that kind of stuff, that crossover is really interesting. But if you're just trying to teach a particular part of the scientific inquiry cycle, then doing method results conclusion is not going to add anything to that. So you don't need to do that. Everyone just pick a focus, and that's the bit that's the focus for recording and attention.
Absolutely. Yeah. Remember your so what, your reason why. Brilliant. Before we wrap up, I just wonder, we said we would leave some links in the description for the resource you talked about in the Not So Quickfire 5. I wonder if there are some links for TAPS and any other tools that you might like the listeners to access.
Yeah, definitely. We'll put some links in the blurb underneath, so that you've got a link to the pyramid bit if you wanted to look at examples of practice, and then the focused assessment database. So on the PSTT website, you can just pick which topic whether you want a lesson plan or whether you want an example of work or whether you want some guidance about it, and then it will filter and you can find examples of things that you can try out in your class. So yeah, we'll stick some links below.
Amazing. Thank you very much, Professor Sarah Earle. I have to say it at least once. I still can't believe it's been such a privilege to have you on the show, and thank you so much, honestly, for your time.
Oh, it's been great having the chance to talk all about primary science, my favourite thing. Have fun, everyone.
And that's a wrap on today's show, everyone. A huge thank you to Sarah for joining us and helping us to navigate those tricky waters in assessing the inquiry skills in primary science. Hopefully, we can all now feel a little bit more confident in our ability to assess inquiry and then turn that into actionable, meaningful classroom practice.